Okay guys, so this is going to be our final video over series, and we're going to focus on Taylor series and Maclaurin series. Okay, so our Taylor series is always centered about A, right here. And remember what we do when we do Taylor series, we take the derivatives, or they're given to us, and we just plug into this format right here. So it goes right the first term, derivative times x minus a, second derivative over 2 factorial, third derivative over 3 factorial, and the pattern just continues on forever. Okay. Now, a Maclaurin series is the same thing as a Taylor series, but it's centered at about 0. So it's pretty much the same exact thing. Okay, so when we find a 4th degree Taylor polynomial, that means we're going to take 4 degrees. Okay, so write the original is e to the 3x, and then I'm going to take the first derivative, which is 3e to the 3x. The second derivative is 9e to the 3x. The third derivative is 27e to the 3x. And the fourth derivative is going to be 81e to the 3x. Now, it says it's a Maclaurin series, a Maclaurin polynomial, so we're going to plug in a 0 for each of those. Okay, so when we plug in a 0, we should get 1, 3, 9, 27, and 81. Remember, e to any power is going to be e to the 0 power is 1. Now when we go to write our 4th degree Taylor polynomial or Maclaurin polynomial, write the first term plus 3 times x plus 9 over 2 factorial x squared. And then we're going to do 27 over 3 factorial x cubed plus 81 over 4 factorial x to the 4th. Now, if we want to go through and simplify this stuff, be my guest. 2 factorial is 2 because it's 2 times 1. 3 factorial is 3 times 2 times 1, which is 6. And 4 factorial is going to be 4 times 3 times 2 times 1, which is 24. Okay? Okay, next one. It says we're going to write the 5th degree Taylor polynomial for natural log of x minus 1, and we're going to center it about x is equal to 2. Okay, so we're going to start by writing our original function. F of x is equal to natural log of x minus 1. The derivative of natural log is du over u, so it's going to be 1 over x minus 1. And I'm just going to rewrite it as x minus 1 to the negative 1 power. Okay, second derivative is going to be negative 1 times x minus 1 to the negative 2 power. Third derivative is going to be 2 times x minus 1 to the negative 3 power. And don't forget your chain rule in there, guys. It's not going to affect anything, but just make sure you account for it. The fourth derivative is going to be negative 6 x minus 1 to the negative 4. And our 5th derivative, because it says we got to do 5th degree, so we got to go 5 derivatives. Okay, is going to be 24 x minus 1 to the negative 5 times 1. Now, we're centering this at 2. So we're going to plug in a 2 for each one of those. Oop, 2. Okay, so we're going to plug in a 2 here. Natural log of 2 minus 1, natural log of 1 is 0. F prime of 2 is going to be 1/2. Okay. No, it's just 1, sorry. 2 minus 1 is 1. So anytime I plug in a 2, I'm going to get a 1. So it goes negative 1, 2, negative 6, and 24. Okay? So when we go to write our Taylor polynomial, I'm going to write it up here. Write the first term is going to be 0. Second term is going to be 1 times x. And we're centering it about 2, so it's x minus 2. Minus 1 over 2 factorial times x minus 2 squared. Plus 2 over 3 factorial times x minus 2 cubed. Your fourth term is going to be negative 6 over 4 factorial times x minus 2 to the 4th power. And our fifth term is going to be 24 over 5 factorial times x minus 2 to the 5th power. Okay, so if you want to simplify that, be my guest. 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120. Okay. Next example, it says let g be the function that has the derivatives of all orders for real numbers. So it gives you the information, it gives you your derivatives. Now it says write a third degree Taylor polynomial centered about x is equal to 5. So t3 of x is going to be equal to, we write the first term as 3 minus 2 times x minus 5. Gosh darn it. Yeah. Plus 7 over 2 factorial x minus 5 squared. And then minus 3 over 3 factorial times x minus 5 cubed. Now, when we go and plug this in, so it says we're going to find the Taylor series polynomial. So this one's actually probably easier to simplify because we're going to end up having to plug in the calculator, so you might as well go ahead and do it. 3 factorial 6. So in a lot of these, it's going to ask you to approximate a value using the Taylor series polynomial or Taylor polynomial. So we're going to take the 4.9 and we're going to plug it into the function in our calculator. Okay. So using our calculator, we're going to put this into y equals 3 minus 2 times x minus 5 plus 7/2 times x minus 5 squared minus 1/2 times x minus 5 cubed. Go to our table, and you get 3.2355. And that's our answer. That's how we do that. Next question is very similar. So these work the same way if it's given it as a table or if it's given as written like this. Okay, or even if it's written as a graph. On some of the ones that have graphs, you're going to get like your slopes from the graph, so that'd be the derivative. And you can kind of tell the concavity of stuff by the second derivative graph. Okay, so it says write the third degree Taylor polynomial for f about x is equal to 0. So it'll be a Maclaurin polynomial. Use it to approximate f of 0.2. So our polynomial is going to be 5 minus 3x plus 1 over 2 factorial x squared plus 4 over 3 factorial x cubed. Okay. So if I go to simplify, it looks like that. Okay. Now, if I'm going to plug in a 0.2, I'm going to use my calculator. So plugging this function in the calculator, you should get 4.4253, just like we did in the last problem. So 5 minus 3x plus 0.5x squared plus 2/3 x to the third. Our table, and we're doing at 0.2. So that's what we should get. Okay, write the fourth degree Taylor polynomial for where g of x is equal to f of x squared. So what this means is we're going to take an x squared. So we're going to take an x squared. So I'm going to just write g of x is equal to f of x squared. I'm going to take an x squared. I'm going to plug it in everywhere there's an x. Okay. Okay, so when I simplify this, I get 5 minus 3x squared plus 1/2 x to the fourth. Remember, you square a squared, it's to the fourth power. And then we get 2/3 x to the 6th. Now it says it wants a fourth degree Taylor polynomial. This is 6 degrees, so we just scratched it out. So your Taylor polynomial is going to be 5 minus 3x squared plus 1/2 x to the fourth. Part C, it says write the third degree Taylor polynomial for h of x is equal to the integral of f of t. Okay, so your f is right here, and I'm going to integrate it. So h of x is equal to, it'd be 5x minus 3/2 x squared plus 1/6 x to the third plus 1, so it'd be x to the fourth, divided by 4, it'd be 1/6. Okay, so that's our Taylor polynomial for the integral. Now, it says you want the third degree. So we're not going to deal with the fourth degree, so your answer is just 5x minus 3/2 x squared plus 1/6 x to the third. Okay, it says let h be defined as in part C. Given that f of 1 is equal to 3, either find the exact value of h of 1 or explain why it's not possible. It's not possible because h of 1 is represented by this right here, the third polynomial for h. Now, as we continue this on forever and ever and ever, we're not going to know what those values are because we're only doing a third degree polynomial. Okay, so it's not possible to know the approximation. I mean the actual value of h of 1. Okay, so it's not possible because f of 1 and f of 0 are the only things we know, because we know f of 0 from up here, and f of 1 is equal to 3. And it is approximation. I really don't like this last part of this question. It's kind of confusing. So anyways, that's Taylor's series, and hopefully you get through the free response and you're able to do those correctly. Just make sure you take your derivatives and go through the process. So if you have any questions, feel free to reach out. Hopefully you have a good evening. Thanks. Bye.